Welcome to the second in a series of 3 modules on designing out waste. The first module provided an introduction to designing out waste, explained the context and the need for waste reduction in construction projects, and how this fits in with the wider suite of policies to reduce construction waste streams. This second module will explain the key techniques that can be used by designers to reduce waste, and then examine the tools and guidance which are available to assist in this process. The third module will present a series of case studies to illustrate how designing out waste can be achieved in practice. In this module, we will cover the 5 principles of designing out waste. We will then demonstrate how the existing design review process on construction projects can be used to encourage all members of the design team to think about wastes from all aspects in order to identify opportunities for reductions. Lastly, we will look in more detail at the tools and guidance documents that are available to help designers in this process. RAP has developed a number of exemplar case studies on live projects, working with design teams to identify and build the business case for action around designing out waste. This work has improved the current understanding of how to reduce construction waste in design, and has led to the development of 5 key principles that design teams can use to reduce waste. It is important to point out that these are not completely new principles which have been developed. Many of the examples which we will provide under each principle are used regularly in construction at present. Taken together, these principles provide a systematic structure which can be implemented when considering all aspects of waste reduction and involving all relevant parties to the design and construction process. We will now briefly look at each of the 5 principles in turn. Underpinning the first principle of design for reuse and recovery is an implicit hierarchy from a materials point of view. In most cases, it is better to refurbish than to rebuild, as the embodied energy of refurbishment is generally lower than that of demolition and rebuilding. However, some buildings are best not retained. If you can't refurbish, then can any elements, such as the structural frame, be retained? If this is not possible, what elements can be removed and then the materials reused in their current state? Once all these options have been exhausted, residual waste materials should be recycled on-site or off-site wherever possible. A number of generic techniques for reusing and recovering materials on-site are listed here. As mentioned, many of these techniques will be familiar to you, but are primarily used for engineering or financial reasons rather than to reduce waste. However, this does not mean that the additional benefits achieved, such as reducing waste and other environmental impacts, should be discounted or devalued. In order to maximize design for reuse and recovery, it is useful to work through a number of key questions as suggested here. You can begin by asking whether any materials from any demolition process can be reused in the design. Basically, this amounts to working with what you've got, as this will be the cheapest option, and in some cases the reuse of original materials can help a new building fit in with its surroundings. For materials which need to be brought onto the site, normally the majority of construction materials, the aim is to maximize the percentage of recycled content, as this indirectly stimulates the recycled products industry as opposed to the use of virgin materials. It is also important to consider how easy the new materials specified will be to reuse and recover at the end of the life of the building. Demolition companies and waste management companies are already starting to come across materials from newer buildings which are extremely difficult to recycle or recover. The second principle, design for off-site construction, involves manufacturing and pre-assembling building components in a factory. This can contribute to reducing waste in a number of ways. Primarily, waste from a factory environment is usually much lower than on a construction site due to the controlled environment and processes. Quality can be improved, and there are usually fewer snags to resolve. The number of journeys to sites will also be reduced. There can be a net reduction in accidents. Construction programs can be tightened, and the number of trades on site for key components can be rationalized. The use of off-site construction is most common for modular elements such as timber or steel framing systems, concrete casting, and so forth, and more recently, bathroom and toilet pods. It is important to consider this option at the earliest possible stage in the design process, REBA stages A and B, as decisions about using off-site construction have implications for the overall design and need to be factored in as early as possible to be successful. The key questions to ask in terms of off-site construction are very simple. Firstly, can any part of the design be manufactured off-site? The design tools which we will look at later in this module will help architects and designers assess this question. Secondly, to what extent can the work on-site become one of assembly rather than construction, so that little or no waste is generated on-site and quality can be driven up at the same time as cost and risk are reduced? The third principle, design for materials optimization, aims to reduce waste streams on-site. There are three main areas in which waste reductions and cost savings can be made. Firstly, excavations should be minimized so that material does not have to be distributed elsewhere on-site or removed altogether. Secondly, the standardization and simplification of materials, sizes and components will lead to a reduction in the different types of materials on-site and a corresponding reduction in the number of waste streams generated. Thirdly, dimensional coordination can deliver waste savings by minimizing offcuts. Rather than leading to boring design, this can have positive effects, as repetition on elevations is usually attractive. In terms of materials optimization, simplification is often overlooked as a means of reducing both cost and waste in construction projects. This could involve reducing the number of materials, as the issue often becomes apparent once detailed design drawings are available. Of course, the simplification of materials can have an impact in other areas of the design process, and it can have effects on both planning and building control. Building to standard material dimensions will help to reduce cutting and jointing on-site. Incorporating repetition within the design will reduce the variety and amount of waste streams from the materials brought onto site. The fourth principle, design for waste-efficient procurement, involves improving the procurement process to reduce waste. Contractors often use consolidation centres and just-in-time delivery to reduce damage to materials from inappropriate storage and handling on-site. However, designers can also take action by considering how work sequences affect the generation of waste and identifying how design choices could lead to the generation of waste. Once understood, waste can be reduced through improved design, specification and procurement. For example, reducing the different types of plasterboard specified will reduce the overall volume of offcuts and unused material. Alternatively, involving specialist or experienced contractors earlier in the design process for certain jobs can reduce waste, as they are more likely to use their materials more efficiently and identify problems which could result in more waste being produced. Of course, designers don't normally procure services except where they are acting as project managers on smaller jobs. However, they can have an influence on project programming, either explicitly through contractual requirements or implicitly through design that leads naturally to logical work sequences. For example, getting all first fix electrical work done before plasterboarding commences. On unusual projects, designers can require enabling works to be carried out first, improving overall project efficiency and reducing waste. In terms of key questions, it is important that research is carried out by designers. Firstly, designers should look at generic research on typical waste streams for the type of project and the associated wastage rates, and secondly, to assess the question of on-site waste generation for the particular development under consideration. RAP's net waste tool can be used to help forecast the waste streams and volumes of waste which will be produced on a project. This will be explained in more detail later in this presentation. Contractors will often have good ideas for reducing waste and improving sequencing, as waste is a cost to the main contractors and in some circumstances for specialist contractors. Often, a more general review of material selection may uncover alternative materials or construction processes that produce less waste. The fifth and final designing out waste principle is designing for deconstruction and flexibility. While this may not produce immediate benefits for the designers and contractors at the time of building, this is best practice for the future and will ultimately reduce waste streams. Much of the waste generated by demolition occurs because buildings were not designed originally with demolition in mind, and a significant proportion could be avoided if materials can be separated out again effectively. Again, this principle should be addressed at the earliest possible stage in the design process, especially where change of use could potentially occur during the life of the building. Designing for deconstruction will also reinforce the first principle of maximizing the reuse and recovery of materials. Many buildings are converted for different uses during their lifetime. Waste will be minimized in this process if buildings are designed to be adaptable. This may mean, for example, making services distribution readily accessible or screwing rather than gluing finished joinery such as skirting boards. Steel frames are more easily dismantled and recycled if joints are bolted rather than welded. There are a number of challenges associated with designing for deconstruction and flexibility, as it is difficult to ensure that the design information is retained throughout the life of the building. This is generally longer than the involvement of the original professionals, and information does not tend to be transferred when buildings change hands. To address this problem, materials can be marked with their original specifications, which will also help in any future repair and maintenance. Utilizing techniques such as building information modeling can bridge the information loss associated with handing a project from design team to construction team and to the building owner or operator, and eventually the demolition contractor. A building information model is a digital representation of the physical and functional characteristics of a facility and can be used as an information source to support decision-making about a facility throughout its operational life, from the earliest conceptual stages through design and construction, and then through its operational life before its eventual demolition. We have briefly demonstrated how the 5 principles of designing out waste provide a systematic structure to consider all aspects of waste reduction involving all parties to the design and construction process. So to recap, the first principle, design for reuse and recovery, involves developing designs that maximize the reuse of existing materials on site and recover the maximum amount of demolition materials where applicable. The second principle, design for off-site construction, aims to take advantage of any opportunities to use off-site manufacturing and construction on a project. The third principle, design for materials optimization, aims to reduce waste through simplifying and reducing the number of materials used for construction. The fourth principle, design for waste-efficient procurement, involves trying to embed efficiencies throughout the construction procurement process to reduce waste. The fifth and final principle, design for deconstruction and flexibility, aims to look to the future and to design for potential changes in building use and ultimately for reuse of materials when the building comes to the end of its life. That concludes our look at the 5 principles of designing out waste. We will now take you through the designing out waste process to show how these principles can be applied effectively in practice. One key thing to point out from the outset is that the process of designing out waste does not require a completely new set of technical solutions or a major addition to the normal flow of design work. It does, however, require a consideration of waste and resource use during the design process, and a willingness to investigate solutions and vary the design approach depending on the project and the particular resources and constraints of the site under development. Designing out waste can be achieved through a simple structured approach as outlined by the 3 steps: identify, investigate, and implement. The first step in this staged approach entails identifying opportunities for design solutions which reduce materials consumption as well as waste generation. At this point, it can also be useful to form a judgment as to how easy the resulting design changes would be to implement. The second step is to investigate the proposed solutions and to quantify the potential benefits in terms of both materials use and waste generation. Potential solutions can be prioritized according to their ability to deliver these savings, and then weighed against the other considerations of design, such as acoustics, aesthetics, cost, etc. Potential design changes also need to be assessed for viability and buildability. The third step is to decide upon the changes which are viable and then implement the agreed solutions. These agreed actions should be recorded in the Site Waste Management Plan as part of demonstrating good practice and communicated fully to the contractor when appointed, as a record of the design decisions which have been taken. Recording via the Site Waste Management Plan also helps to ensure that the agreed measures are understood and subsequently implemented, and not value engineered out at a later stage. The first stage, identify, can be easily completed by undertaking a simple design review or workshop. The form of this review or workshop can vary depending on the size of the project, type of contract, and nature of the work, and should be appropriate to the size and nature of the project. For many projects, particularly large ones, say over £5 million, a formal facilitated workshop is often a good way to carry out the design review. However, an informal internal workshop or meeting may be more appropriate for small projects or standard work packages. Whichever option is chosen, it is desirable to involve a range of stakeholders in order to obtain a mix of ideas and perspectives. In either case, the most appropriate time to do this would be at REBA Stage C, ideally prior to the submission of the outline planning application, as there can be implications for size, layout, and built form. A facilitator's pack for the design review workshop is available from the RAP website. Formal workshops are most effective if they are broken down into discrete stages. We have provided a typical breakdown of a workshop as shown here. The purpose of the awareness session is to ensure that all participants are familiar with the aims of the workshop, and then to introduce the drivers for waste reduction, which were explained in the first module of this presentation. The second session on creativity aims to generate a wide range of ideas for design changes that have the potential to reduce waste, using facilitation such as post-it notes to ensure that all ideas, no matter how seemingly improbable or insignificant, are captured. The reasoning session aims to classify each of the ideas according to the 5 designing out waste principles outlined earlier, estimating the potential impact on waste and the ability and ease of implementation in the project. Ideas can be prioritized before the next session, selection, where the best ideas are retained for further investigation. Feedback and discussion are used where the workshop is large enough to be split into smaller working groups. In order to facilitate the selection process, it can be useful to categorize ideas in terms of impact on waste production and ease of implementation. Most materials reduction measures lead to cost savings, but if there are cost increases, then they should also be considered at this point. Looking at the y-axis in the diagram, top to bottom, allows us to chart an identified idea against the potential impact on the volume of waste generated. The x-axis, left to right, allows us to chart an identified idea against the difficulty of implementing within the project. The impact on waste generation at this stage is an estimation. Later in the design process, a more detailed assessment can be achieved using the RAP net waste tool, and ease of implementation can be assessed by looking at implications for cost, program, procurement method, and availability of materials. The intention of this matrix is to focus on and investigate the ideas which land in the A box, as these are the most likely ideas to be successful and easiest to adopt on a project. RAP have developed a suite of tools and guidance to assist design teams in the designing out waste process that we have just been describing. These tools are intended to assist all the parties in the design and construction process and the waste handling process itself. The RAP Designing Out Waste tool for building and civil engineering projects can be used to provide an indicative waste forecast, which can inform the design review workshop by providing direction for ideas. The outcomes from the design review workshop can then be fed back into the RAP Designing Out Waste tool to allow a high level of quantification of the impacts of the ideas identified upon the volume of waste generated. This in turn can be used to provide the indicative waste forecast used in the site waste management plan. The remainder of this module will look at some key guidance documents that are all freely available through RAP. A key guidance document for the design stage of a building project is the RAP document Designing Out Waste, a design team guide for buildings. The guide, which is supported by REBA, is aimed at construction clients, contractors, and design teams, and explains the process of designing out waste and introduces the principles and tools available. In addition to the description of the 5 principles of designing out waste, this design team guide also contains a series of suggested waste reduction initiatives. These have been broken down according to the 5 principles. As with all the guidance produced by RAP, the guide is available in both electronic and printed form. The equivalent guidance for civil engineering projects is Designing Out Waste, a design team guide for civil engineering. This guidance is split into 2 parts, as this guide was developed more recently. The first part is similar to the design team guidance for buildings projects, as it contains an introduction to the principles and processes of designing out waste. The second part presents a range of technical solutions that can be applied to different types of civil engineering projects. Importantly, this guide is recognised and endorsed by the Institution of Civil Engineers. As well as the design team guides, there is a series of more detailed technical guidance available. This will help designers to make the best use of demolition materials, maximise the use of reclaimed materials, and identify the recycled content of building products so that the specification can maximise the use of recycled materials and help improve the market for the recycling process itself. We will now quickly run through the main points in the guides shown. The Efficient Use of Materials in Regeneration Projects guide is applicable to any project which includes either an element of demolition or the reuse of some existing building elements. The guide presents a step-by-step process for linking the demolition phase of the project to the new build phase, so that existing resources on site can be retained and incorporated effectively in the reconstruction. The guide also covers the use of materials reclaimed from other sites, which is especially effective if they are nearby. The ICE demolition protocol is incorporated within the guide, as are the principles of good site waste management. The Reclaimed Building Products Guide is useful to both designers and contractors, as it provides detailed guidance on the specification and procurement of recycled materials. Clearly, in order to comply with building regulations, minimum performance levels must be met, so this guide provides indicative performance data on a range of building material types. The guide also provides information on particular aspects of reclaimed materials, which need to be considered in both their specification and use. For example, there may be a greater degree of natural variation in reclaimed products, such as bricks, than in those produced using modern manufacturing techniques, and this needs to be taken into account in the design, procurement, and construction phases. The RAP website includes an online directory of recycled products to accompany the hard copy guide. This searchable database contains a vast number of mainstream construction products with their recycled content stated. The manufacturers have provided this information in line with the rules of thumb criteria for listing on the website. This enables designers to identify product replacements to increase the recycled content of a project without changing the specification. This provides a benchmark for existing supply chains to provide information on recycled content and to challenge suppliers to beat the levels listed. Using the recycled content directory is simple. For example, if you select Board and All Suppliers, you will be presented with a list of products and the percentage recycled content for each product. By clicking on the brand, you are directed to a more detailed description, including certification information, a breakdown of the recycled components, and a link to the manufacturer's website. We have shown a sample of the output from the recycled content directory in the table here. RAP has produced a suite of tools for forecasting, managing and measuring, and reporting waste to cover each stage of the construction process. All of the tools are available free from the RAP website, together with instructions on how to use them. Video tutorials are now available to accompany each tool and provide step-by-step guidance on how to use them. The Designing Out Waste tools, the Net Waste tool, and the Site Waste Management Plan template are aligned with and can assist with the 3 stages of the Designing Out Waste process: identify, investigate, and implement, as seen here. That brings us to the end of this second module on Designing Out Waste. So, to recap, we have looked first at the 5 principles of Designing Out Waste, and then explained the design and review process in terms of identification, investigation, and implementation. Lastly, we have introduced the various tools available to help designers, including guidance, project information, waste forecasting, and measurement tools. That concludes the second of the 3 modules in the Designing Out Waste series. The third and final module in this series presents a number of case studies of different construction projects, so that designers can see how the principles of designing out waste have been applied in practice, and how the available tools have been used to drive down the volume of waste and its associated costs. Thank you for listening.